Good morning. We are on October 6th, 2018 in Hong Kong for the 22nd International Congress on Parkinson's disease and movement disorders. I'm Dr. Broussolle, Professor of Neurology in Lyon University Hospital in the south of France, and I am very happy to introduce the interview of Professor Ho from the Hong Kong University Hospitals. So could you tell us about your present position, professional position, Dr. Ho?
Sure, thank you. Well, first of all, I'd like to thank you for this kind invitation. I didn't expect it. I'm absolutely flattered and honored to be here for this interview. Well, I'm the present Chief of Division of Neurology in the University of Hong Kong. I wear several caps. I am also the Chief Neurologist for the Queen Mary Hospital, which is the affiliated teaching hospital to the University of Hong Kong. And the University of Hong Kong also runs another hospital across the border in Shenzhen, and I also help look after the services on that side of the border as well. Okay. So it's basically wearing a clinical cap as well as an administrative cap. And I also have responsibility over my research team. I have a research team doing basic sciences, mainly on Parkinson's disease, on the various aspects of Parkinson's disease.
Thank you. Could you tell us your background in terms of high school and then medical studies and residency and,
sure.
and until the present position, please?
Sure. It's been a very varied thing because I was born in Malaysia. I went to school. I went to primary school and secondary school in Malaysia until the fifth form, which is about age of about 15, 16. And then I went to boarding school in UK in a town called Canterbury in Kent in England, where I spent 1.5 years there. Hated it because it was a boarding school, very regimented type thing, but it gave me a fresh perspective on other cultures. And from there I went to medical school in Cardiff, and then from there I went to various centers of training in England, mainly England, from Cardiff to Birmingham, Coventry, Manchester, and back down to Birmingham. And prior to my job here, back in '94 in Hong Kong, I was a clinical research fellow at the University of Birmingham. So right. It's been a long journey. So yes. I've spent now 24 years now in Hong Kong.
Very nice.
But I spent 14 years in England, in the UK, basically.
Another important question is, how and why did you orient your research and clinical practice to neurosciences and more precisely to Parkinson's disease and movement disorders? Yeah,
like many things in life, there's a bit of everything, a bit of luck, serendipity, opportunity at that time, the people that you admired, your mentors. So all those, it's a complex combination of various factors that make you go down that route of neuroscience and Parkinson's. And I suppose during that time, exciting things were happening in Parkinson's, certainly. At that time, I remember the time when I was doing my clinical fellowship, the thing about the data study findings that was published in, I think it was 89 or something along those lines. And I just caught onto that sort of bandwagon, that fever, jumping on that, and I thought, oh, that's pretty exciting, something that we can seriously do something about. And I following that data study publication, I then thought maybe I should do a dissertation on an enzyme called monoamine oxidase B. And they thought that perhaps that by doing something to this enzyme, you could actually slow down the disease. And so that's the sort of perspective that you're talking to. And then from there, I jumped into a clinical research fellowship on looking at Parkinson's disease. I suppose also at that time, there was a chap, a neurologist that I truly admired, a chap called, I don't think you've probably heard of him, but a chap called Mike Sandbrook. Mike Sandbrook. He had quite a big influence on me taking up neurology. He truly was one of the traditional British neurologists that was based on clinical skills, and more importantly, I think his humanity towards his patients. I think the way that he spoke to his patients, the way he might sit down with the patient and very patiently talk to them, hear them out, comfort them. I think that really had a big influence, big impact on me when I was training. That really was a thing, because it's easy now to get lost in all the technology, in the busy thing. Very often in the clinics, you often think, how much time you offer to each patient. And I think we probably lost some of that. But anyway, that's a story. But in a certain sense, I think this neurologist, Mike Sandbrook, he's long retired now, but he had a big influence on me, and I suppose from there, with all the other combination, that's how I somehow got into. I suppose there's a lot of so many factors coming in. There was the job opportunity that came out, at that time, and it just so happened that there was a clinical fellowship available. That I went into Parkinson's.
Thank you. Are there some leaders that had a strong influence in the field of Parkinson's disease, therapeutic or clinical practice, or basic science researchers?
Well, certainly, early stage, as I've said, the people like Mike Sandbrook, made me think about neurology and Parkinson's disease as a field to be interested in. I think it's always the people that you have close relationship with that tends to influence you most. There are many world leaders and world authorities on Parkinson's, but I think one of the people that I find that I again truly admire is Yoshi Mizuno.
Japan.
Of Japan, yeah. I've known him since, I think, going back to 97. First time I actually met him was in a meeting in Malaysia, in Kuala Lumpur, where I come from. And we were on the airport leaving together after the meeting, and we just managed to sit down, and I know he likes noodles, and we went off to a cafe and we had an opportunity to chat. But about Yoshi, basically he's not only a truly great scientist, but he's also a great clinician. But on top of that, the thing that really I feel that made him out, he was he had possessed that true sense of humanity. I think that's something, and his humbleness, his genuine humbleness for all his true achievements. It's incredible, and I think that that's a lot, truly remarkable legacy to emulate. I think that to me is a great thing. There are, of course, many others, but I do not know of them, in a personal sense than somebody like Yoshi.
Thank you. Could you please tell us which particular research field you worked on? You developed, you spoke, for example, about MAO-B inhibitors, but you did many publications, and could you summarize the most important research, there are several, that you did during the last 20 years or so?
Sure. Well, my interest in Parkinson's disease, really, in terms of my first dissertation was really on monoamine oxidase B and its relationship to Parkinson's. And then I went on to look at, to try to find out, why do women, patients, premenopausal, their symptoms fluctuate with their menstruation cycle? And that was interesting. I thought, and why was this difference between the gender difference in terms of prevalence between women and men. As you know, men tend to have a slightly higher incidence and prevalence of Parkinson's until they reach an age where they become postmenopausal. And that sort of interests. And my first PhD student that I had, Zitao, who is now actually working in Chicago now, we started looking, well, let's just look at this enzyme, COMT, and he looked at this and found some interesting elements in the promoter region of COMT, and he found some estrogen receptor elements that control COMT. I thought, maybe we could look at it. He characterized the gene, and then we started testing this thing on our patients. And also, so we then found out that estrogen can actually downregulate COMT, just like what entacapone does. So it was almost like an endogenous COMT inhibitor, and we showed that. And we then actually did a very small clinical pilot blinded trial of testing a low dose estrogen on a small amount of a small number of women, postmenopausal women, and we did find that it did almost like have this improvement in the UPDRS motor scale, small but significant. Even though it was a fairly small number of subjects. And so that was how it started. And then we moved on from there towards looking at mitochondrial dysfunction. And in a certain sense, I suppose, looking at mitochondrial dysfunction now, I certainly believe that it's certainly part of the pathogenesis of Parkinson's disease in a vicious cycle. And we did look at it specifically from the aspects of a set of proteins called mitochondrial uncoupling proteins, and we published on that. And we had then moved on from that onto looking at LAC2, and we then managed to create a model, an animal model of a LAC2 knock-in model to explore, not so much looking at LAC2 as the mechanism of how LAC2 contributes to Parkinson's, but really trying to use that as an experimental platform to mimic as closely as possible to what happens in humans. So we have published on a combination of using long-term, treating mice over long term of oral rotenone, given dose, mixed in with the genetic susceptibility of LAC2 knock-in mutation, along with aging. So we gave these mice almost half their lifetime of a very, very tiny dose of rotenone to mimic our exposure, of lifelong exposure to insecticides. And we did find it was interesting that these mice were far more susceptible to developing these motor deficits compared to wild type that were exposed to the same dose of rotenone. And now I hope we will publish, so I don't know yet, we have submitted our publication and looking at alpha-synuclein in this animal model and looking how we can reduce the amount of alpha-synuclein buildup, specifically looking at oligomeric alpha-synuclein, how we can actually reduce that down in our animal model. And we have to produce, we had produced several novel assays to prove that we're actually reducing down alpha-synuclein in these mice. And it's interesting because these LAC2 mouse that we have, they are knock-ins mouse of LAC2. They have this nice buildup of alpha-synuclein as they age. The mice live for about 2 years. And this buildup of oligomeric alpha-synuclein in the striatum starts from about 12 months old. That means half their lifetime. So an equivalent would be about 40 years of age. By the time they reach 80, you can see a nice gradual build-up to a significant level. So these knock-in mice truly have got this trigger susceptibility in these in the build-up of alpha-synuclein. So that is where we are at this moment. So one of the things that we are trying to target is looking at how we can use our own body defenses to try to reduce down alpha-synuclein, namely the autophagic pathway. So the work that we recently just completed was on chaperone-mediated autophagy. We are looking at macroautophagy as well as mitophagy. So those are some of the exciting developments that we are doing currently in terms of research.
Excellent. I saw that you also did some research on ALS.
Yes.
Could you tell us a little bit about this?
Yeah. ALS. The thing is that, you know, like in all neurodegenerative diseases, you know, you see that they have upstream mechanisms. The upstream pathogenic mechanisms tend to be very different, but downstream they tend to be similar. Whether you're talking about Alzheimer's, that sort of thing, except in ALS they maintain their cognition. In ALS, I started off actually with some research on ALS and PD. It was almost like a hedging, you know. If something doesn't come up with this, we will look at this. And so I had to hedge my bets, if you like. And ALS just turned out at the time to offer an opportunity because it's a fascinating neurodegenerative disease where you've got specific muscles with preservation of certain muscles that tend to be intact. For example, the extraocular eye muscles are intact even in the very, very latest stages of the disease. And why are those preserved whereas some of the others are not? So that's a question that I've never answered. Another one was trying to answer whether there was a genetic susceptibility. Whether there was a genetic susceptibility? What drives it? Why is it that the same mutation, for example, SOD1, within the same family, I've got a huge family of SOD1 mutations, you know, with a familial autosomal dominance in Hong Kong. Some of them would die within 6 months, and some of them, I had one live for about 14 years. Same family, same mutation. What drives it? Well, there are various hypotheses from modifier genes and all sorts of things. And we had recently published on one where there was a burden of these rare variants. That means the more of these rare variants or mutants that are associated, and these are all on its own, doesn't seem to be much in a way that it influences the progression of ALS. But if you put them all together, they must be operating within the same pathogenic pathway, but they are all scattered around. And we just haven't found, you know, it will take time to try to link up how these genes link up and give you that vicious cycle that eventually leads down to the downstream downstream pathogenic processes that eventually leads to this devastating process. But one of the things about ALS is it's a very depressing disease to research it, because it's something that you feel you can diagnose, but unfortunately, you know, the treatment options are so limited. And so in a certain sense, not so much thing, but really to look at a different disease would give me a different perspective.
Very nice. What about the 10 years that are ahead of this meeting? What do you think about the new frontiers that could come up in Parkinson's disease research and movement disorders more generally?
Yeah, I think certainly for the next 5, perhaps 10 years, again I speculate, I think there will be a lot better models. You've ever heard of it this morning, you've heard some of that, and you've heard some of the exciting development within this Congress and outside of this Congress. You can see that there are huge amount of technological advances in our experimental methods, you know, in cellular biology, molecular biology, and more importantly, in neuroimaging, and more importantly, how they are able to merge all these technology into a coherent pathway, into a coherent methodology that integrates all these various techniques to be able to answer our experimental questions. I think that's one of the points I can think. I think neuroimaging, the neurooptics in the pathways where they are able to explore how these pathways degenerate and how from the cellular level all the way up to the network level, I can envisage that to progress incredibly fast. I can see the experimental methods and experimental models will come out to really accelerate the next 10 years.
What advice can you give to young medical students and young neurologists for the next decades for their career?
Well, when I was doing my clinical research fellowship, it was always said that neurology, oh, is so boring. You can make the diagnosis, but you cannot do anything about it. My key advice now to both clinicians and neuroscientists is the best is yet to come. Neuroscience lags behind oncological cancer research, partly because of complexity of problems, of the questions that we have to answer. I can remember that, how simplistic our idea of each neuron is, the morphology of each neuron. You've got the cell body, a short axon, you've got a synapse, and it then communicates from the synapse. It was really simplistic, and now we can truly realize how big that magnitude of that problem is. But with the technological advances, I can sense it now that within the next 10, 15 years, I think there'll be some breakthroughs coming through with the development in neurosciences that will translate into clinical neurology, and specifically Parkinson's disease.
Okay, next question is, if you could wind the clock back 20 years, do you think you would have oriented differently your career, or would you have do the same as you did?
Yeah, I don't think so. I mean, if where I'm sitting now, I don't think I would. But again, if I were to turn the clock back 20 years and start again, I would be influenced by so many other factors. Job opportunities, what are the current progress in whatever fields of research, funding, the people that you work with. So many of them would drive your decision. So if you were to turn the clock back 20 years, I might end up in a completely different pathway. Who knows? I could have ended up, I don't know, being a banker or an accountant or something else. It would be difficult. Well, perhaps 20 years would be too short, because 20 years ago I was in Hong Kong. So, but I think probably not. If it was 20 years. But if you say that turn the clock back 40 years, maybe, but not 20 years.
What about the contribution of the Movement Disorder Society to Parkinson's disease and movement disorders research? What do you think was the contribution of this society, and what would you expect more from MDS in this field?
When I first started, my very first meeting in the MDS meeting, I clearly remember it. I think it was in '92 in Munich. Yes, how I remember that it was in Munich was because during the meeting, I had, by luck, to see Michael Jackson. On that day, I bought the ticket on the same day as his concert. So that's how I remember it was '92 in the Munich Stadium. And it has gone truly from what seems like a North American, European organization is truly expanded into a truly global organization now. You can see it year from year from year from year with the various sections. It has a huge, tremendous influence on how movement disorders and Parkinson's disease is practiced, with all the various guidelines, with all the rating scales coming through. So that has really gone from what seems to be an European American organization expanded into this truly global organization. And I suspect that's probably the largest, biggest influence on how people think about Parkinson's disease and movement disorders. how will it, how else would it expand? I suspect that on this trajectory, I suspect that Movement Disorder Society will probably be bringing in more of its expertise from developed countries into developing countries to extend that reach into those areas which don't have access to this sort of healthcare thinking on Parkinson's as well as movement disorders.
Thank you very much. Last question. Did you experience bias or barriers during your career? And what would you do to, if so, what would you do to improve the situation?
I must say that I've been very fortunate. Been very fortunate not to really experience, or at least in my own self. Even if I did, I probably didn't feel it. Because in a certain sense, I tend to be an optimist. If there's a certain barrier there, I would find ways to go past it in order to reach a certain goal, because there are many ways to reach your goal. It's not only one route. So if one were to encounter a barrier there, are there other things to bypass that? I suppose this question, I think, is probably more relevant towards my female colleagues, where, in general, biological constrictions in the sense that they have children to help bring up. And certainly, I have a lot of empathy with that. Two-thirds of my team are female, so I have a lot of empathy towards that thinking. But in a certain sense, they bring in a lot of different perspective, sense of maturity to my team, because finding that work-life balance, people who can find a truly good work-life balance always, I find, are very productive. You don't have to always spend your time in the wards or in the outpatients or in the clinics or in your lab to be able to find that contribution. For example, you can hear from this morning's plenary from Marie Vidier, who managed to set up that good work-life balance. I think that's important. I think that question, I suppose, certainly from my perspective, I thought it was more towards addressed towards a female gender in terms of progression in their career. But I think that once they go past that time when they have sleepless nights bringing up the baby and that sort of thing, I think once they go past that, they catch up. They catch up with their male counterparts, and that's where I suppose that's where I'm truly lucky. Because I've never really encountered that sort of barrier. And certainly in Hong Kong, we don't get that because Hong Kong, as you know, it's mainly based on merit. If you are able to get to do what they want or what is required and what the aim is, I think you will get there. I think in a certain sense, biases and things like that, very much in a certain sense is also from within. If you feel that, the world is always against you, it's much harder to initiate things. I tend not to think along that sort of mindset. On the whole, I tend to be much more optimistic that things can be done.
When about the Congress, are you happy with the fact that the Congress was this year in Hong Kong, and was it a lot of work for you to participate to the organization of the meeting, and also what did you get back from the experience of such a meeting in Hong Kong?
Yeah, well, I must say that I must admit that I didn't really contribute that much to the organization of the meeting in Hong Kong. That's why I need to congratulate the organizers, the local organizing committee in Hong Kong. As you know, I'm sure you have organized meetings in MDS before. It's very well run. It's extremely well run in the sense that the participants are well taken care of, free Wi-Fi, and the Wi-Fi works, and and everything is all sort of in terms of organization of the congresses each year. It has always been a very, very consistently, if anything, has always made that improvement from year to year to year. I have attended other conferences from other organizations. I always find that MDS is one of the better, one of the best organized congresses. Of course, I am very proud that it's in Hong Kong for the first time. You know, it's always nice to welcome MDS to hold this meeting in Hong Kong. It's a truly global city, and I'm sure many of the local organizing committee members, my colleagues in Hong Kong, are truly very proud to host the MDS in this meeting.
Thank you, Dr. Ho.